On this 2014 to 2018 GMC Sierra 1500 with the 5.3 gas engine, we're focusing on P0101, mass airflow sensor performance. In plain terms, the ECM may be seeing measured intake airflow that does not line up with what the engine model says it should be. The truck may idle poorly, hesitate, feel down on power, or simply turn the MIL on.
Possible fault areas can include the air induction path, MAF sensor contamination, sensor power, ground and signal circuits, and related map or throttle inputs. The key is to prove which side of the system is wrong before condemning a part. This is not just a simple high or low MAF code. The MAF sensor normal frequency parameter range is 2000 to 10,000 Hz, but P0101 is really a rationality check. The ECM compares calculated airflow against the actual measured values from the MAF, MAP, and throttle position inputs. The monitor gate is engine speed between 450 and 6,200 RPM, engine coolant temperature between -7 to +129 degrees Celsius, +19 to +264 Fahrenheit, and intake air temperature sensor 1 between -20 to +129 degrees Celsius, -4 to +264 Fahrenheit. When those gates are met, it runs continuously. P0101 sets when the measured airflow is not within range of the calculated airflow for greater than 2 seconds. Start with the basic system checks, then follow a structured diagnostic approach. With ignition on, first make sure there are no related reference voltage or sensor supply codes taking priority. If those are present, diagnose that problem first. Next, look at throttle body idle airflow compensation. It needs to be less than 90%. If it is 90% or greater, handle throttle body cleaning before going deeper into this P0101 path. Then run the throttle sweep and make sure throttle position sensors 1 and 2 show agree. If they show disagree, stop and diagnose the throttle position issue first. Next, determine the current testing altitude and compare the MAP sensor pressure to the correct altitude versus barometric pressure range. If you do not have that pressure range available for the altitude, do not guess that part of the check. Pause and get the correct range before moving on. After that, with the engine idling, verify the MAP sensor parameter is between 26 to 52 kPa, which is about 3.8 to 7.5 psi, and make sure it changes with accelerator pedal input. If MAP is out of range or does not respond, diagnose the MAP path first. If MAP checks correctly, continue with the MAF verification. Now, watch the MAF sensor G per hour parameter. At idle, use the scan tool snapshot. Slowly raise engine speed to 3000 RPM, then bring it back to idle. Exit the snapshot and review the data frame by frame. The MAF value should change smoothly and gradually as engine speed increases and decreases. If it does not, move into circuit and system testing. If it does, reproduce the operating conditions, or reproduce the captured conditions from the failure data, and verify P0101 does not reset. If the code stays gone, the check is all okay. If it resets, go to circuit and system testing. Before circuit testing, complete the verification path. Then inspect the whole air induction system. Look for damaged, loose, improperly installed, collapsed, restricted, or leaking components. Loose clamps, cracks, a restricted air filter, vacuum hose splits, kinks, leaks, or wrong connections, vacuum leaks at the intake manifold, MAP sensor, or throttle body, water intrusion, snow or ice buildup in cold climates, and contamination on the multifunction intake air sensor element. Contamination on the MAF heating elements can slow or distort sensor response. Water or snow can make the signal rise quickly. Also, keep aftermarket filters, aftermarket induction systems, and induction modifications in mind, because they may cause this code. If you find a condition, repair or replace that affected component as appropriate. If the air path checks out, continue into electrical testing. With ignition off, disconnect the harness connector at the B75C multifunction intake air sensor. Test for less than 2 ohms between ground circuit terminal 7 and ground. If it is 2 ohms or greater, disconnect the sensor chassis ground and test the ground circuit end-to-end for less than 2 ohms. If that end-to-end test is 2 ohms or greater,
repair the open or high resistance in the circuit. If the circuit is less than 2 ohms end-to-end, repair the open or high resistance in the ground connection. If the ground test passes, turn ignition on and verify a test lamp illuminates between ignition circuit terminal 5 and ground. If it lights, move to the signal circuit. If it does not light and the fuse is good, turn ignition off, remove the test lamp and the fuse, and test the ignition voltage circuit end-to-end for less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, verify the fuse is not open and there is voltage at the fuse. If the test lamp does not light and the fuse is open, test for infinite resistance between the ignition voltage circuit and ground. Less than infinite resistance means repair the short to ground. If it is infinite, test for greater than 2 ohms between ignition voltage circuit terminal 5 and ground. Less than 2 ohms means repair the short to ground. Greater than 2 ohms means test the components connected to that circuit and repair or replace as necessary. Be careful here. Internal ECM or sensor damage may occur if the circuit is shorted to B+. If the ignition feed test lamp illuminates, keep ignition on and test for 4.8 to 5.2 volts between signal circuit terminal 6 and ground. If the signal is less than 4.8 volts, turn ignition off. Disconnect the K20 ECM connector and test for infinite resistance between the signal circuit and ground. Less than infinite resistance means repair the short to ground. If it is infinite, test the signal circuit end-to-end for less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, replace the K20 ECM. If the signal is greater than 5.2 volts, turn ignition off, disconnect the K20 ECM connector, turn ignition on, and test for less than 1 volt between the signal circuit and ground. If it is 1 volt or greater, repair the short to voltage. If it is less than 1 volt, replace the K20 ECM. If the signal is between 4.8 to 5.2 volts, decide whether the EL38522A variable signal generator or an equivalent tool is available. If it is not available, test or replace the B75C multifunction intake air sensor. Then operate the vehicle under the monitor conditions or the captured failure conditions and verify the code does not reset. If it resets after that branch, replace the K20 ECM. If the generator is available, connect the red lead to signal circuit terminal 6 at the harness connector, connect the black leads to ground, and connect the battery voltage supply lead to B+. Set the signal switch to 5 volts, the frequency switch to 5 kHz, and the duty cycle switch to 50%, normal. With the engine idling, verify the scan tool MAF sensor parameter is between 4,950 to 5,050 Hz. If it is not in that range, replace the K20 ECM. If it is in range, test or replace the B75C multifunction intake air sensor. After the repair, keep verification separate from testing. Reproduce the operating conditions, confirm P0101 does not reset, and make sure the vehicle still passes the earlier checks instead of assuming the last part touched fixed it. Takeaway: P0101 is a rationality problem, so prove the air path, MAP and throttle inputs, power, ground, signal, and sensor response in order. For more diagnostic training, visit stepdiagnostics.com.